Hello student, welcome to my YouTube channel. Today we are going to learn vectors. But before going forward vectors, we will what define our what objective or what aim. Our main target is to understand what physics. To understand physics, what are the facilitators? First we have to study. In this regard, study of what vector makes understanding of physics simpler. So, vector actually in physics we are studying the different physical quantity or interrelation between what different types of physical quantities. So first we have to see कि what are those quantities? Is there any classification? Yes, there are what so many bases of what classifications. And here, if we are assuming कि just by dividing the what whole physical quantity on the basis of their direction, then the quantity, the whole physical quantities can be defined or classified into two groups or two classes. One class is that is what is scalar and another class is what vector. Now question is what here why I have what uttered the word scalar, because any physical quantity, if it is what a physical quantity, then definitely it must have what measurement, and measurement means what numerical addition of any physical quantity or numerical representation of what any physical quantity is nothing but it's what measurement or what scalar part, or we can say scalar part is nothing but the measurement of what physical quantity. So that is scalar. Yes, so scalar quantity which is not having any magnitude but it has only, suppose it has what only magnitude, it has no direction. So on the basis of what the direction physical quantity can be classified into scalar, and another one will be what a vector. A vector. Scalar quantity, it has only magnitude like magnitude like 10 kg of rice, 15 kilometer. So, and suppose 10 ampere of what current, etc. These are what the quantity. It is the quantity of, we'll see what in mass, this is what distance, this is what current, all these quantities. Yes, if I am saying what 10 kg of rice, it is giving you the what complete meaning, complete sense. 15 kilometer of what distance, it gives the what complete sense and complete meaning, and 10 ampere of current, it also gives the what complete sense. Now see, if I am saying yes, velocity is equal to 10 meter per second. Velocity is 10 meters per second and force is 10 Newton. It has no meaning. If I am saying what the velocity is what 10 meter per second, it has no meaning. And if I am saying what if a force is equal to what 10 Newton, it has also what no any meaning. Then if I am saying if velocity of a particle or velocity is 10 meter per second towards east, meaningful. If I am saying what 10 Newton is what suppose we applied on a what particle or body now vertically downward, then it has what meaning, otherwise not meaning. So now see, if I am saying what 10 meter per second towards east, so this towards east or east direction is making this quantity whole as a what vector. And if I am saying here 10 newton acting vertically downward or vertically upward, it makes a what vector. So there are a what quantity, the other class of what quantity other than scalar is what vector, and it has what magnitude as well as what direction, magnitude as well as what direction is the simple address or what suppose ki a definition of what a physical quantity, which is or what vector. It means it has what direction as well as what magnitude. It means what definitely as far as what measurement is concerned, yes, definitely it defines the what magnitude, and direction here is coming the another. That's why we will what study here here we are not going to stress some on what scalar. In this particular chapter we are going to what stress maximum on what this vectors. So here is what vector, and now we are going to what start what is suppose after knowing what is vector and what is the importance of what vector in physics, because either the physical quantity will be vector or will be a what not vector. So it means what if we are knowing the properties and what we suppose properties of what vector, then definitely we will be what able to interact with those what vector physical quantity. Now, so first thing is how to represent, how to represent how to represent a vector. How to represent a vector means what here, how suppose if any physical quantity is there, and if you want to represent yes it is a vector, then we are generally taking what a line segment which is defining the magnitude or representing magnitude. I am saying what if this is the what line segment, this is representing the magnitude. It is not measuring the magnitude, this is representing, this is what symbolically here representing the magnitude, and the arrowhead is defining its what direction. If I am saying suppose we can write what if something is what moving from what a to b, then we can represent what ab as a vector. If you want what represent this, yes we can represent what this like what this. And if suppose here sometimes in what press media or in books, publishers are what or the authors are using bold faced letter, bold faced letter to represent to represent represent a vector, a vector. Like what if I you want yes a b a b, or you can write what a, yes it means what whether you are understanding or not, yes people will understand what suppose who is having what idea about what vector can understand yes ab is nothing but what is a what vector. So it means what the vector is represented by an arrow. Length of the line segment defines the what represent the magnitude, and arrowhead is defining its what direction. Yes ab you can use representation a vector a vector b vector c, you can represent suppose a vector, and if you want you can also represent the vector by using what bold faced letters, bold faced letters. Now suppose if you have what represented a what vector, If you have what suppose you have represented a vector. Suppose if you have represented a vector, suppose A is a vector, a vector. A is a vector. What is its? What is its magnitude? If somebody is asking, what is its what magnitude? And how you will what represent the magnitude of a what vector? Magnitude of a vector, magnitude of a vector is represented as mod of A, or simply we are saying this is A. This is also the measurement measurement of a vector, measurement of a vector, or this is also called the scalar aspect of a vector. Not only this, you can also say yes, the statistical portion of a physical physical quantity, that is also the magnitude. So magnitude of what a physical quantity, yes, it is the representation, it is the what operation. Here mod is what operation it gives when you are putting a vector behind the bars or within the bars, or what mod. It means what it is representing, its what magnitude, its measurement, or its what numerical part of a physical quantity. Numerical part of a physical quantity is always a what vector. So this is the representation of what vector. So see, first we have seen why we will study vector, because there are so many physical quantities. Some are what vector, some are what scalar. So you have seen there are what vector physical quantity. That's why we will want to study vector, because we want to study or learn the what physics. Second thing, we have seen how we will what represent a vector. Just by observation one can say yes, this is vector, this is what not a vector. Then we have seen if vector is given, then how we can represent its what magnitude, because you have defined a quantity or a vector quantity which is having what magnitude as well as what direction. So it means what, so far you have seen how you will what represent the magnitude of a vector. Now our third aspect here in today's lecture is the different types of what vector. Different types of what vector. Different types of what. So next target is different types of what, types of vector, types of what vectors, different types of what vector. Now first we will take what is a vector, equal vector, equal vector. Two vectors are said to be equal if its magnitude and direction are same. Direction are what same, then we are saying yes, two vectors are what equal vector, equal vector. Now another terminology we are going to take Just I am giving you what simple idea. We will see its what application also. Now it is what parallel vector, parallel vectors, parallel vectors means what? Yes, geometrically two lines. Suppose it is what a vector A and this is what vector B. If there what suppose here magnitude of what A, magnitude of what A may not be equal to what magnitude of what B, but here the vector A may be parallel to what vector B. Possible, this is what possible, this is also what possible. It means what? If their directions are what same, but magnitude may be two vectors may be what of what same magnitude as well as what same direction. Or here see one of the basic difference is what? Here two lines geometrically you can see it is what parallel, but vectorially these two are what directed along the what same direction. So it means what? If in your city, if to a person, if the particular direction is what east, then throughout the what suppose one hemisphere, all for all persons the only same direction will indicate the what east. So it means, but the separation between what the line of sights of what different peoples may be what different, but direction will be what eastward or east only. So line of sight we will say it is what parallel. So parallel vectors. Now similarly we can take what anti-parallel, anti-parallel vectors. Means what? If suppose here we are taking what suppose a vector A and here we are taking a what vector B, then we are saying what? If magnitude of what A may not be magnitude of what B, we can say yes, vector A is equal to suppose k times of what vector B. Means what? Magnitude of what vector A is equal to k times that of what B. It means magnitude of vector A is not equal to the magnitude of what vector B, but the direction of what both are what same. So here we can say A vector is what parallel to what B, but we cannot say here magnitude are what same. Similarly, if we are saying vector A, here see vector A is equal to minus k times vector B. It means direction of what here we cannot say these two are what parallel, but we can say vector A is what anti-parallel to B, but it is not necessary कि magnitude of what A is equal to that of what B. So magnitude of A is not equal to the magnitude of what vector B. So here anti-parallel vector you have seen. So now anti-parallel vector also you can take this as a what? Opposite vector, opposite vector. Now another what suppose the types of what vector, just you see these are not very much what important in the study of what physics, but as far as what basics is concerned, yes, you must have what the simple idea about what this. Now anti-parallel vector also you can call this as a what opposite vector. Now come to the what we are saying next is fourth is free vector, free vector, free vectors. Free vectors means what? What? How? Suppose it means what? Free vector. It does not. It does not include the location of vector. Location of what? Vector. means its location is not specified, it is not tied. Where we will use, we will see in the what, suppose our next, or suppose in the study of what physics, when we will, so many what forces are what acting on a what rigid body, their line of forces or line of actions are what not same, their point of applications are also not same. But if you are dealing with its what, suppose translational motion, then all force vector, all forces will behave as a what, free vector. We can shift its what line of what action and point of what application. Those vector which is not including the location of what vector, means what, which if suppose the in location or location of what vector is not important, then those vectors are called as what, free vector or free. So otherwise vector whose what, which include the what location for the vector, where what inclusion of what its location is important, those vectors are called as what, tied vector. Tied vector, as you will see, in case of what, suppose rotational motion of the same body or rigid body, you are dealing with the what, rotational motion of rotational motion of what, the rigid body. In that case all those vector will behave as a what, sliding vector, but it is not, means what, line of action cannot be shifted, means what, its position of action will not shift or will not change, it will be fixed, and in that case all those vector will behave as a what, tied vector. So the same vector in a given circumstances will behave as a what, free vector, and under the same different circumstances the vector will behave as what, tied vector. Now similarly we can take what, another vector as what, equivalent vector. Equivalent vector. So another types of what, vectors is what, equivalent valent vector. Equivalent vector. Equivalent vector means what, suppose equivalent vector, and then forget about this, means what, here equivalent vector, or before that you take what, this fifth, unit vector. Unit vector. Unit vector. Here unit vector is a vector having a vector. It is a vector having unit magnitude. Unit magnitude. Unit magnitude. Unit vector is unit vector. So magnitude, direction is there, but magnitude is what, always unit, and unit vector representation is also specific. If suppose unit vector is what, eta cap, it is what, read as what, eta cap, that is what, unit vector. Unit vector along x direction, yes, unit vector x cap means what, unit vector along x axis. Y cap, unit vector along y axis. Z cap, it is also called as what, unit vector along what, z axis. Here I cap also can be representing the what, unit vector along x axis. J cap also representing what, unit vector along what, y axis, and k cap also representing what, unit vector along what, z axis. So unit vector, after what they suppose here unit vector means what, you have seen, its what, direction is there, but it's what, having what, one magnitude means what? Magnitude of the what unit vector will be always 1. Magnitude of what unit vector is 1. Now 6 is null vector. Null vector. Here we are saying null vector means what vector we are saying? It means what? Its direction is what? Indeterminate. You can see any direction depending on what you suppose. A particle, it means what? Here, particle, it is what also representing what? Zero vector. It is also called as what? Zero vector. Zero vector. Zero vector. Null vector is what? Zero vector. No magnitude. No magnitude. And direction is indeterminate. Means, suppose if you have thrown a particle against gravity up, vertically up, at the highest point, particle is at instant rest. At that point, somebody will interpret the particle is having velocity what? The velocity, zero velocity towards east. Somebody will what interpret zero velocity towards north. Somebody will what suppose ki, interpret zero velocity towards what downward. Somebody will say what no, it is what zero velocity towards what southward. So anything you can what interpret. That's why its direction is what indeterminate. Whatever because the magnitude is the sub zero. Hence direction it can what occupy any sense or any direction. That's why if somebody will ask you what is the physical significance, the physical significance, physical significance of null vector means what? No, you don't write this. You write what this there is no physical significance of null vector. Why? Why we are saying what there is no any physical significance of what null vector? Because no any because no any physical quantity can be represented represented by null vector. Because null vector demands what? Magnitude should be what? Zero. And a quantity which has to be what? Physical quantity must have what? Magnitude. Here magnitude is not there. So any quantity represented by null vector cannot be what? Physical quantity. So simply it has what we can say, suppose we conclude it has only mathematical significance, mathematical what? Significance we can say. So this is what? Null vector. Now on the basis of what? Suppose the frame of reference or based on the what? Location of observer. Again the vectors are what? Classified into another suppose the type. One is called as what? Polar vector. Just I am giving you the what? Class one by one. Also I'll give you the what? It's what? Application also. So polar vector. These are what the vectors. If under suppose if the observer is what changing its what position or what orientation, this observation does not change. Observation does not change. Suppose a particle is what moving from west to east. To an observer, it is what from west to east. Now, if the observer is rotated by what 180 degree, and this will be the what mirror image of the what previous observer. In the changed situation, the observer also observing the particle is moving from what west to east. It means under the what suppose ki frame transformation, observer's transformation, if the nature of what vector and sense of what vector both are what not changing, then these vectors are called as what polar vector. Polar vector. Polar vector. Nature and sense both remains invariance under what frame transformation or observer's transformation. But if you will take what another vector that is called as what pseudo vectors, it is also called as what axial vectors. If you will take what this here, nature does not change, but sense changes. Like what? If you will take what angular velocity, angular momentum, torque. If suppose the particle is what moving on what this circular path, if you will see the things from what upward, if you will see from the top, and if you will see the things from what bottom, observation differs. If this kind of what vector is there, then those vectors are called as pseudo vector, or we are calling this as a what axial vector. It means suppose here omega, angular momentum tau, etc, or this is what torque, this is what angular velocity, angular velocity, angular momentum, angular momentum, this is what torque, etc are what axial vector. These are what axial vector, axial vector. These are what axial vector. So here the what suppose ki observer is what rotated by what 180 degree, and again if he is what observing the situation, the observation becomes what different. Hence these vectors are what pseudo vector or what axial vector you can say. So just polar vector and what suppose ki yes, it's what explanation will be given while what when you will come across what different physical quantity in detail, because right now we cannot say, because if you are not knowing what is suppose ki vector, what is position vector, what is radius vector, what is velocity vector, what is force vector, because you see axial vector or what pseudo vector always is the vector product of what two polar vector is pseudo vector. Pseudo vector or axial vector is vector product of what two polar vector. So these are what different types of what vector, and hence you can what suppose ki conclude in this session we have what introduced the vector, its representation and its different types. In the next session, I am going to teach you the vector algebraic operation or vector algebra.